two constants then, they help us understand many of those core processes in the universe, from the very small things, the structure of incredibly tiny things, right up to the formation of planets and suns and so on.
Yeah, that's right. So if proton, for example, becomes unstable and there is no star, then if we believe that the early universe consisted of hydrogen, then that star is not going to produce heavy elements. And so there will be no planets and molecular structures.
And so, using these two constants and some pretty impressive mathematics, you were able to find the upper limit for the speed of sound and the material through which that sound would need to pass to get to this high speed. Could you run me through how you've combined these two constants to come to that conclusion?
So we used an equation which is well known. It's an equation that we study in high school for the speed of sound. And then that equation has a characteristic energy that describes how strongly atoms are bound together. And that energy has a characteristic value which is set by the fundamental constants. Once we use that, then we get an equation which now does not depend on material properties, but is pretty much universal. It only depends on the mass of the atom which the solids are made of. And so the equation we have predicts that sound should propagate fastest in the lightest solids. And there is only one that solid, hydrogen. And at room conditions, hydrogen is not solid, it's a gas. But if you go to very low temperatures, it becomes a molecular solid. If you now compress it to very high pressures, it becomes an atomic solid, right? So it just becomes the collection of hydrogen atoms arranged in a crystalline lattice. But that only happens at very, very high pressure.
And so I understand this pure atomic solid hydrogen can only exist in places that are under enormous pressures, places like the center of Jupiter, for example.
That's right, that's correct. So people have speculated that at the center of Jupiter, the hydrogen will exist in a solid atomic form.
And so even though you aren't able to study this in the lab and actually run this experiment because we can't get to the center of Jupiter and run such tests, you do believe that through the modeling that you've done, that you have found this upper speed limit of sound as it would pass through this pure solid hydrogen. So what is the upper speed limit of sound?
Okay, so our calculated upper speed of sound is about 36 kilometers per second, twice as fast as the speed of sound in diamond. And so far, diamond has the highest speed of sound, at normal Earth conditions. It is much faster than the speed of sound in air. So in air, it's around 1 kilometer per second. So our upper bound is more than 30 times the speed of sound in air, but it's still a lot lower than, of course, the speed of light. So the speed of light is 300,000 kilometers per second.
So the very shape and density of the universe is dependent ultimately on the maximum speed of sound, and so is the liquidity of water and else. Kostya Trichenko is Professor of Physics at Queen Mary, University of London. He was with our very own Carl Smith, who often exceeds the speed of sound. Next week on The Science Show, how Rosalind Franklin may fly again and even land on Mars. Production by David Fisher and Simon Branthwaite. I'm Robin Williams, and a very happy St. David's Day, patron saint of Wales.